In this presentation, I'm going to explain different types of energy sources and particularly solar energy source. First, let us see the classification of energy sources, different types of energy sources classified based on its origin, from where it is obtaining. Therefore, the first one is the fossil fuel energy. Fossil fuel energy is crude oil, natural gas, etc. This is fossil fuel energy, nuclear energy, then hydro energy, that is from water stored in a dam like that, hydro energy, solar energy, wind energy, biomass energy, geothermal energy, tidal energy, and ocean thermal energy. All these are the different energy sources that is classified based on its origin. Now let us see another classification, that is what we call conventional energy sources and non-conventional energy sources. Now coming to the conventional energy sources, the different conventional energy sources are, first one here, hydro energy. Let's say that comes around 29 percentage, and next one, coal is there, that's around 29 percentage. Next, nuclear energy, that's also conventional energy source, that comes around 28 percentage. Then crude oil 7 percentage, natural gas 7 percentage. All these are called conventional energy sources. Now coming to the conventional energy source, that is called conventional energy source, in that one, that comes around 29 percentage. That is, advantages are, that is abundantly available. It's a most abundant fossil fuel, and 300 years at current consumption rate, it is available for 300 years, and high net energy yield also. These are the advantages of this coal. But of course, a lot of disadvantages are there. That is, it is the dirtiest fuel, highest carbon dioxide emission. That is one of the major disadvantage. Then major environmental degradation is there. Then major threat to the health, and major raw material for many other industries. These are using as a raw material. Therefore, these are the disadvantages of the conventional energy source coal, which is available around 29 percentage. Another conventional energy source available is the natural gas. That's around 7 percentage only. That consists the mixture of different gases like methane around 50 to 90 percentage, and ethane, propane, butane, and hydrogen sulfide. All these mixture of all this one makes the natural gas. That comes around 7 percentage only. That's another type of conventional energy source available, natural gas. The another conventional energy source available is the crude oil. Crude oil is also around, of course, 7 percentage crude oil. That is a liquid mixture of hydrocarbon with sulfur, oxygen, and nitrogen. Of course, there is sulfur dioxide, nitric oxide, and air pollution. These are the impurities that will be producing in this by using this one, and that comes around 7 percentage of that total conventional energy source, and that is formed from the formed from the remains of plankton, that is alga, bacteria, and protozoans, and the plants, animals in the shallow seas millions of years ago. That is, after this much millions of years, millions of years, this will forms the natural gas, and maybe pumped up or maybe under pressure. And important producers are OPEC, Alaska, and in Siberia and Mexico. These are the main producers of the crude oil. That comes around 7 percentage total energy, conventional energy source. The next conventional energy source is available is hydel power. As you know, that hydel power, in that one, the water is kept at a high, say, dam, and then that the potential energy of that one is used to convert into the electrical energy in the generating station. And here the advantages are, it's a clean fuel, non-polluted, can be used for irrigation also, apart from the energy protection. Their irrigation purpose also can be used. Energy cost is very low and used as a peak load plant. These are advantages of hydel power conventional energy source. Disadvantage is that displacement of local communities to be displaced, and the inundates, that is overflow of flood or water, low lying area, the water will be overflowed, and it is expensive to set up. Setting up cost is much higher in this case of hydel power stations. Other conventional energy source is the nuclear power. Nuclear power, that is the around 28 percentage. That comes, the advantage helps in reducing the fossil dependency, high energy density, energy of the future, and is energy of the future as such considered like that, and less fuel cost and continuous operation of the plant. That is, these are the advantages of the nuclear power, and it's also a conventional energy source. And disadvantages are, of course, a radioactive waste and expensive to set up. Setup cost is also expensive, like hydel power plant, and external dependency also, the material available for the nuclear fusion fission, that materials are, depending, that should be depend from other countries. For external dependencies also there. These are the disadvantages of nuclear power. That is another conventional energy source. Now the next classification is the non-conventional energy sources. As non-conventional energy sources, that is solar energy. Of course, that will be considering after this one. Mainly we'll be considering the solar energy and the wind energy and the biomass. And biomass is a renewable organic material that comes from the plants and the animals. That's the biomass, another source, non-conventional energy source. And geothermal means is the heat within the earth that is utilized and that is converted as using as energy source. That is geothermal energy source is the. Then energy from the ocean and tidal. This is another source. For these 1, 2, 3, 4, 5, these are the non-conventional energy sources available. And in that one, we'll be more concentrating here solar energy. Continuing the non-conventional energy sources of this one, what are the advantages and disadvantages? Of course, solar energy, wind energy, biomass, geothermal, energy from the ocean and tidal. These are the non-conventional energy sources, and the advantages are it is available in nature, free of cost. That's the first advantage, and less pollution, and inexhaustible, and low installation period. Therefore, these are the advantages of the non-conventional energy sources. This one. And disadvantage is that cost of harnessing energy is high and uncertain availability. It's an uncertain, especially wind and solar is uncertain, and location constraint is there, and greenhouse effect of biogas plant, and noise pollution, wind energy especially. These are the disadvantages of these type of non-conventional energy sources. But of course, there are a lot of advantages. And nowadays, more solar and wind, solar power generations are coming up. Unit is coming, and for non-conventional energy, here mainly we'll be concentrating solar energy, and then we'll be seeing what is the wind energy also. Coming to the solar energy, say sun is the basic source of energy for Earth. Solar energy is available in the form of electromagnetic radiation. Sun is a large sphere of very hot gases, that is heat being generated by the various fusion reaction inside the sun. Sun subtends an angle of only 32 degree. That is, this is the sun and this is the earth. That angle of subtends is only 32 degree of earth's surface because of the large distance between them. Because of the large distance between the sun and earth, it subtends only 32 degree. The sun generates an enormous amount of energy, around 1.1 into 10 raised to 20 kilowatt hour per second. That much energy is generated per second by the sun. Continuing the energy from the sun, because sun, earth is and 1.4 million kilometer in diameter. That is this one, 1.4 million kilometer in diameter. Interior temperature of about 20 million degree Kelvin of the sun. Pressure of about 70 billion times the atmospheric pressure of the earth. Pressure of this one. and creates an ideal condition for the fusion. So these are the ideal condition to produce the fusion inside the sun. Therefore, temperature is 20 million degree Kelvin and pressure is 70 billion times the atmospheric pressure. These condition will be creating an ideal condition to the fusion reaction inside the sun. Therefore, the fusion emits high energy gamma radiation from the interior of the sun that is transformed into low energy radiation as it moves to the surface. And the lower energy radiation means that includes the visible and heat radiation. Visible radiation plus heat radiation. Therefore, Earth orbit has a mean radius of 150 million kilometer. Earth has this one. And radiation from the sun reaches on the Earth 8 minutes. The rate to reach the radiation from the sun to the Earth, that is approximately 8 minutes. Therefore, the solar spectrum can be divided into three main regions. The spectrum, that is the solar radiation spectrum that is reaching at the Earth, that can be divided into three regions. One which is called ultraviolet, second one is called the visible region, third one is called infrared region. That is based upon the wavelength as such. Therefore, if wavelength is less than 0.4 micrometer, that is ultraviolet region. In that one, around 8.3% of irradiance is coming under that. And if the lambda or the wavelength is between 0.4 micrometer and 0.7 micrometer, that the visible region, that comes around 42.3% of the irradiance. And the third one, that is the infrared region, which is more than lambda or wavelength is more than 0.7 micrometer, that is about 49.4%. Therefore, these are the three categories of the main regions of the spectrum region as such, solar spectrum region: ultraviolet region, visible region, and infrared region. Now, solar energy, that is the solar energy is the radiant energy and heat, radiant light and heat. It irradiates both light as well as heat from the sun that can be harnessed, that can be extracted as such. Therefore, the important features of the solar energy, that is the energy that's sun, the source of solar energy is a huge glowing sphere of hot gas with 1.4 million kilometer diameter, and most of the gas is hydrogen, it's about 70%, and helium about 28%. And due to the nuclear fusion reaction of the hydrogen and helium, internal temperature reaches to over 20 million Kelvin. That is what happens in the sun. Now, continuing this introduction to solar energy, the resulting loss of mass due to the fusion is converted into electromagnetic energy, that's power, that radiates outward from the surface into the space. From the surface into that space it is coming. And the spectrum of the solar radiation is close to that of black body at 5800 degree Kelvin. And the amount of energy reaching the surface of Earth every hour is greater than the amount of energy used by the Earth population over an entire year. That is per hour, every hour, that's the energy if you calculate, that is more than the amount of energy used by Earth's population over an entire year. That much energy is reaching from the solar system. Now come to the solar energy on Earth. The Earth's outer atmosphere intercepts about 1 2 billion of the energy generated by the sun, or about 1500 quadrillion, or 1.5 into 10 raised to 18 kilowatt per year. Due to the reflection, scattering, and absorption by the gas and aerosols, that is small particles suspended in the air in atmosphere, due to this absorption in the atmosphere, however, only 47%, that is 7 into 10 raised to 17 kilowatt per year, reaches the surface of the Earth. That is only 47% of this is reaching on the surface of the Earth. For the solar radiation is received, there are two ways. One we call it as directly it is reaching, that's called the direct radiation. Another one is by diffusion in the air, dust, water, etc. That's called the diffusion radiation. For the total radiation, that's called the global radiation, is sum of the direct radiation plus and diffusion radiation. Therefore, direct radiation plus diffusion radiation, that is the total global radiation from the sun. Therefore, the amount of incident light per unit area and day depends upon the number of factors. The amount of incident energy that depends upon per day or per unit area, that depends upon different factors. The first one is that solar radiation, that is geometry, which includes the solar angle, locational or geographical factors, and season times of the year. All these factors will be affecting the incident amount of incident energy per unit area. Another one is the local climate is also as another factor. Another factor, third factor, is that inclination of the collecting surface in the direction of the sun. All these three factors will be affecting the incident energy of the solar energy per unit area. Let us see the different terms used in solar energy. That's irradiance, irradiation, and insolation. Three terms: irradiance, irradiation, and insolation. Irradiance means it is the rate at which the radiant power incident on the surface unit area, or that is equal to that much watts per meter square. Unit is watts per meter square, and it is expressed by the simple capital G. Therefore, this is the irradiance. And irradiation is the incident energy per unit area. It's energy. It's not a power as such, energy. It is the actually joules per meter square. Therefore, that is actually integrating this one. The power is integrated, is determined by the integration of the irradiance over a specified time, or maybe hour or day, that will give irradiation. Therefore, irradiation is the integration of irradiance over a certain period, either hour or a day. And the third one is called insolation. Insolation is a term used to indicate solar energy radiation, that is short wave radiation, and its insolation is an abbreviation of the incident solar radiation, that is incident IN, solar SOL, radiation TION. Combining this one, we'll get what is the insolation. Therefore, insolation is a term used to indicate solar energy irradiation, short wave radiation. Now let us see the difference between extraterrestrial and terrestrial solar radiations. What is the difference between that one? Okay. Now let us see solar radiation incident on the Earth's atmosphere, which is known as extraterrestrial solar radiation and is relatively constant. That is radiation on the Earth's atmosphere. On Earth's atmosphere, that is called extraterrestrial. Extraterrestrial is mean extra, that is coming on Earth's atmosphere. But the radiation at the Earth's surface is not atmosphere, Earth's surface, which is known as terrestrial solar radiation, and it varies widely due to, that is not constant like Earth, this extraterrestrial, but that is varying due to different condition, that is atmospheric effects including absorption and scattering, local variation in temperature atmosphere such as water vapor, clouds, pollution, latitude of the location and season of the year and the time of the day. All these three factors will be affecting this one, second one, terrestrial solar radiation. But extraterrestrial solar radiation, that is constant, that is almost constant, that is relatively constant as such. That is the radiation at the Earth's atmosphere. But terrestrial solar radiation is the radiation at the Earth's surface. That is that's affected by these three, or that is affected by these three factors. For the above factors have several impacts on the solar radiation received at Earth's surface. Now let us see the characteristics of solar radiation and radiation spectrum as such. This is the radiation spectrum, solar radiation spectrum, in which this is the spectral irradiance in watts per meter square plus nanometer, And here this is wavelength nanometer versus spectral irradiance in watts per meter square per atometer, and that is the solar radiation, in which the yellow one is the sunlight at the top of the atmosphere, and here this is the radiation at the sea level as such, and this is the black body spectrum as such. And here the characteristics of the solar radiations are best explained with the help of the solar spectrum plots, which give the data on the intensity as the spectral content. Because the spectral content as that. Therefore, if you see the based on the wavelength, this is called the ultraviolet, and this is the visible one, and this is called the infrared region. UV, visible, and infrared region is the this is the wavelength as such, and these characteristics are normally known as extraterrestrial above the atmosphere level and the terrestrial level, that's sea level. Terrestrial level means sea level or the surface of the earth, in comparison with a standard black body at 5800 degree Kelvin. The solar spectrum typically extends from the infrared to the UV region wavelength, and the length of region 0.2 micrometer to 0.3 micrometer, where but intensity is not uniform. Therefore, that is the solar radiation spectrum that gives solar irradiance in watts per meter square plus nanometer versus wavelength in nanometer. Now, in the next presentation, we will be continuing the second part of the solar energy.